Hello, you are welcome to the session. It's about chemical equation, one of the fundamentals of chemistry. If you're actually going to enjoy chemistry, then know what chemicals are about to be able to balance. You should, of course, know the types of chemical reactions. So that's what this is about. Alright, so let's look at the objectives for this session. Now, by the end of the session, you should be able to one, define a chemical equation, balance a chemical equation, state the types of chemical reactions, and finally, write combination reactions. So let's start with our first objective, that is definition of chemical equation. Now, when we say chemical equation, we are referring to a symbolic and quantitative representation of the changes that occur in the process of chemical reaction. In chemical reactions, there are bonds broken and there are new bonds formed. But we try to represent this symbolically and quantitatively in order to make its study simple and easier. So for example, we can have an equation xa plus yb going into p, c, and qt. Now this is a symbolic and quantitative representation of a hypothetical reaction. For this thing that we have written, A and B are the reactant, which in most cases, for this very arrow that we see there, the reactants are at the bottom or at the tail of the arrow. So the arrow over here points to the right and it shows the direction of the reaction. That is an irreversible reaction which only moves from the left side to the right side. So A and B are the reactants, whilst C and D are the product. Like I said, this arrow there represents an irreversible reaction. Now, what about the X, Y, P, and D? They represent the relative numbers of moles or the stoichiometric coefficient of the reactant or the stoichiometric amount of the reactants and the product. So that is for chemical equations. Now when you write chemical equation, you cannot just leave them right like that. There is one thing that you need to do, that is to balance the equation, and so that's our next objective, balancing chemical equation. When do we say an equation is balanced? It is when the same number of atoms of each element appear on each side of the equation. We will look at examples, but a balanced equation, once again, conforms to the law of conservation of matter. In other words, we are writing an equation in which we are not creating matter or destroying matter. So an example is what we have here, where iron combines with oxygen to form iron oxide. Okay, so that's iron 3 oxide. This is an equation. How do we balance it? How do we ensure that we have conserved matter? So in the balance, let's look at the left side. What do we have there? How many atoms do we have there? The right side too, what do we have there? First, we have one atom of iron, and then we have also two atoms of oxygen. At the right side or the product side, we have two atoms of iron, and then we have three atoms of oxygen. So looking at this, it's not balanced. Okay, if this happened to be a seesaw, then we'll have one side close to the ground and the other side far in the sky. So what do? We have to ensure that we now have a balance. That is to say, the number of atoms of iron and oxygen at the left side will be the same as those on the right side. So to balance the number of atoms, or to balance the number of oxygen because at the right side we had 3 atoms there, and then at the left side we had 2. We write 2 in front of the oxygen molecule, that is at the left side. In that case, we now have 3 moles of oxygen molecule. And so the number of oxygen atoms at the left side has now increased to 6 because the 3 is multiplying the 2. So we have 6. Now, if we do that, then we have to go back. We have to go to the right side. And when we go to the right side, our focus shouldn't be on the iron, but it should rather be on the oxygen. That is what we have targeted to balance. If we go to the right side and we decide to focus on the iron instead of the oxygen, then we are going to find ourselves in troubles. It's the oxygen that we are working on. Let's finish with it. Now at the right side, there is a subscript, which is 3. So what do? We only have to multiply it by 2, and that gives us 6. One thing that you should also note when balancing equation is that we manipulate coefficient. We don't manipulate subscript, okay? The moment you go and type the subscript, you have changed the whole of the compound. So for example, we have Fe2O subscript 3. And because at the left side we now have 6 oxygen atoms, you go to the product side, and then instead of the 3, you rub it off, and then you write 6 there. You have changed the whole compound. So we are writing it as a coefficient, that is 2. So we are done with the oxygen. What else do we have to do? We now have to come back to the iron to also work on it. Interestingly, because iron at the reactant side is standing alone, it is quite easier balancing it. We just have to go and check for the number of iron at the product side, which in this case we have 4. Why 4? There is 2 at the back, or there is a coefficient of 2. That 2 is multiplying the subscript, which is also 2. So we have 4 atoms of iron. That means that we come back to the left and we put 4 before the iron. And so our balanced equation is now 4 moles of iron reacting with 3 moles of oxygen molecule to give us 2 moles of iron 3 oxide. After this, we need to check to be sure our equation is balanced. How do we check? We just have to check the number of atoms for a particular element. Then we go to the other side to also do the same. So for the iron at the left side, there are 4 moles. At the right side, or there are 4 atoms of the iron at the right side. There are also 4. Oxygen, we have 6 at the left side. Oxygen, we have 6 at the right side. So our equation is balanced, and this works for all equations. The next thing to look at is the types of chemical reactions. One is direct union or combination. We will be looking at them one after the other. 2, we have decomposition reactions. We have displacement reaction. We have metathesis or double displacement. And finally, we have the combustion reactions. Let's look at the direct union or combination reactions. In the direct union or the combination reactions, 2 or more substances will combine to form a single product. So at the right side of our equation, we are only expecting just one compound there, one species there, one product. At the left side, it could be 2, 3, or more, but they will all have to come together to give us the product. So An example is when we have a hypothetical equation where A is reacting with B, but that is not going to give us C plus D, but it is giving us AB. And with this type of equation or reaction, it usually occurs between certain species. One is a metal ion and a non-metal ion. So, for example, we have ion 2, ion 2 ion, which is a metal ion, and then sulfide, S2 minus, which is a non-metal ion. So these two, when they come together, they form a single product. That is iron sulfide or ion 2 sulfide. 2. Metal oxide and non-metal oxide. So, for example, calcium oxide. Calcium is a metal, and then the oxide, and then the non-metal carbon and the oxide. When these also come together, they form a single product. That is calcium carbonate. Another is between non-metal and non-metal. Two non-metals, they can come together and we expect only a single product. For example, carbon and oxygen coming together to give us carbon dioxide or carbon 4 oxide. That is also a combination reaction, and we can even get it from the name combination reaction. My good friends, this is where we end our session. Now I'm leaving you with these questions. Please try them and let's meet in the next session. My name is Robert Shumesi Kuma, and thank you very much.